Well, we're going to continue with a newer topic, even though a lot of what you learned in the previous material, particularly creating formulas, is very, very vital to actually being successful with this topic. So if you've still not mastered or you still have any questions pertaining to creating chemical formulas given a name, then it's high time you go back and refresh your knowledge on those topics, right? Now, what is the purpose of this particular video is, as a nurse or a doctor or even a science professional, you probably have heard of the word concentration, okay? When you get a substance in a bottle or vial, whatever, it's got some concentration, okay? Sometimes you may use it as it is, or sometimes you may be required to dilute the dosage and give it to a patient or an animal, whatever you're into. So to ultimately get there, to be able to calculate concentrations or dilute concentrations and stuff, we have to really understand the meaning of a mole, and that's very, very foundational concept. So this is where we're going to start our journey and work our way slowly up to a point where you should be able to calculate molar mass. And you would clearly see and appreciate how everything you learn is used in every single place to really make sense of the chemistry behind whatever you're trying to do. All right, so a mole is, you have an element, right? Say phosphorus or sulfur. There's something that makes up the sulfur. You know, you have so many atoms, right? And each atom contains electrons, protons, neutrons, right? When you add the mass of that, how much of it is contained in that element, that is called a mole, okay? I've tried to explain that in the simplest sense possible, okay? A molar mass is, if there's a way you can actually measure how much of that is contained, then that is the mass of that substance contained per mole of that substance, and that's called molar mass, okay? If that made zero sense to you, we're going to move on, okay? And that's the periodic table that you are familiar with. Now, the first thing that I wanted you to introduce to you, I wanted it to be easier, so you get some connection to the concept without me getting too far in and then make a mess out of it, okay? We're going to actually calculate the molar mass of a compound, okay? And that's first thing. And here's something I want you to know. These are conversion units, which you don't need it for this particular problem or material contained in this video, but as we move forward, we need to be able to go from moles to atoms, moles to molecules, and so on. You do not have to memorize this, people, in both in-seat and online. This will be attached to the exam in the appendix for the in-seat people. For online people, you can always access this. This conversion, you do not have to memorize, although you don't need it for this particular material, but I'm giving this so that you know that something else is coming down the road. All right, as I said, I want you to be able to successfully come up with chemical formulas, okay? I would rarely give you the actual formula because if you graduate from my class and I've always made everything easy for you, then you have really not learned anything, and you may never even appreciate what you've learned prior. So I'm always going to give you a name and then have you come up with a formula, so make it a little hard for you purposefully. All right, so chromium-3 carbonate. Your first job is to, the question is asking, what's the molar mass of these four compounds? Well, in one case, I have given you the formula, but in the three cases, I have given you the name. Chromium-3 carbonate. Chromium is a metal, transition metal, so Cr. The 3 goes with the chromium, and it's a metal, so it's plus. And if you're having your little table by your side, you see carbonate is CO3 2 minus, that's inside the bracket. Now we swap, so we get Cr2, CO3, 3. That's the formula for chromium carbonate. All right, let's keep going, actually come up with the formulas. Magnesium oxide. Magnesium is an alkaline earth metal, so it's in 2A, so it's 2. And magnesium is a metal, so it's plus. Oxide is coming from oxygen, which is 6, so 8 minus 6 is 2. and oxygen is a nonmetal. So they actually cancel out, giving you MgO. That's B, right? Calcium chromate. Well, calcium is an alkaline earth metal as well, so it's 2 and a plus. Chromate, if you look at your table, is CO4 1 minus. So we swap. So it's CaCrO4, right? Good. And close the bracket and put the 2 here. That's calcium chromate. And D, we just have actually given you the formula of. If I ask you what the name is, can you do it? It's a question. Well, that's for food of thought. Anyways, how do we go about actually calculating the molar mass? Well, if you go to the periodic table, you see the atomic mass for chromium is 52, right? So 52 times 2, okay, this is for chromium carbonate. Okay, I always put as many brackets as possible, plus 3 times carbon is 12, plus 3 times 16 for oxygen is the atomic mass. So total this out, so which will come out to be 52 times 2 plus 48 plus 12 times 3, right? It's 284 grams per mole. Now it's important, this is the molar, we basically use the atomic mass to get the molar mass, but the unit is very important. We get 284, what do we put it next to it? It's 284 gram over 1 mole. Start writing this way. You might see textbook or some other people write it this way. They're both correct. But please stick with this for now, and I'll tell you why I had you write this way versus this way. They're both right, okay? But please, please do this for now, because it will help you when you do calculations then this way, okay? All right, let's keep going. Magnesium's atomic mass is 24.3. You don't necessarily have to use the decimal, but you know, it's up to you. I don't care. I mean, here I'm using the decimal. Plus oxygen is 16. I always round off because, you know, when you're short on time on an exam, it's easier just to round off everything. So it's 40.3 grams over 1 mole. That's the molar mass of that. Similarly, calcium is 40. Again, I'm rounding off just 40 plus 2 times chromium is again 52 plus 4 times 16 for oxygen. So let's add this up. So it's 64 plus 52 times 2 plus 40 is 272 grams over 1 mole. Please write it this way. Like I said, you're doing yourself a favor by learning this way versus that. All right, let's move on. So tin is 118, about 118, plus sulfur is 32, plus 4 times oxygen is 16. That will be 118 plus 64 plus 32. It's 214 grams over 1 mole. And this is exactly how you would calculate molar mass given the formulae or a name where you come up with the formulae. All right, so stay tuned.